All right, so we're going into our next chapter. This is going to be on data protection. So data protection in AWS is crucial for ensuring data integrity, confidentiality, and compliance with regulatory requirements. Okay. It helps prevent unauthorized access, data breaches, and financial losses, and it also supports compliance obligations. So robust data protection is essential for building a secure and trustworthy cloud environment. So what are we going to do today? We're going to do some data protection tracking, and I'm going to do some walkthroughs on this. So what you could do is look at what is anything that revolves around encryption in flight. That means TLS and SSL. All right, so in the console, which you're looking at, you should look at any console endpoint. That could be S3, that should be EC2. Notice that all URLs have HTTPS. You see that highlighted there in the taskbar? Okay, this confirms that TLS is used. And TLS is managed by AWS Certificate Manager, excuse me. To view this, you can type in Certificate Manager and get this here. Okay. You can also hit on the 9 digits and then go for, let's see, Security, Identity, and Compliance, Certificate Manager. And from here, you can choose between public and private certificates. You can also set up and provision a certificate and request one from here. You can add a domain name and validate ownership via DNS or email. And you can use services like CloudFront for HTTPS content delivery, load balancers to secure traffic to EC2s or containers. You can use API Gateway with custom domains. So this is relevant to the exam because TLS encryption ensures data confidentiality in transit. And it's a common question. It covers HTTPS enforcement and using the certificate manager. So let's go and get you an example of what we can do. All right. So let's go to S3 and let's select a bucket. Let's try this one. And let's go for the properties. I believe properties. Okay. And then we can go for encryption. All right. So let's see. The default encryption is set here. Server-side encryption with S3 manage. Let's click edit. And from here, you can choose from 3 different types. We could have SSE S3, which is what we have. Server-side encryption from S3 managed keys. We can do KMS, which is customer managed keys. Oh, no, this is SSE KMS. This is AWS Key Management Service keys, but this is customer managed. And then you have SSE C, which is not. Oh, this is dual side. Okay, so this is a dual side so that both the customer and AWS can do this. So you have 2 layers of encryption. And then you can choose your key from your keys. I don't think we have. Yeah, we have a handful here. And then we can enter a key ARN that we might have to use or create one itself. And then we can enable or disable this. So the exam will focus on the server-side encryption, whether customer managed or AWS managed. But the dual layer will be on it, but to a lesser degree. This will likely be something in the non-counted, possibly, but you should know it nonetheless. So what you want to do is see whether or not everything is handled and the developer has the correct key to encrypt your data. Why? Because encrypted data means it's secure data, meaning if even someone breaches your infrastructure and gets this data, it is encrypted so nobody will actually know it's there. So you use the keys to encrypt your data and on the other side to decrypt it. So there's no decryption in AWS from AWS. It's used by the customers. This might appear in the exam in any data loss prevention or compliance scenarios. Okay, next we'll go to CloudHSM. That's hardware security management, I believe. SIM. HSM. Let's see. There we go. Manage hardware security module. Excuse me. Okay. And so let's see if we can find this in the hamburger menu. So I would guess it's over here in security and identity. Yeah, it is. So it's managed hardware security monitors. So over here, what you can do is create a cluster. All right. Well, let's go over this. This provides cloud-based hardware security for generating and using your own encryption keys in the cloud. So HSM can manage your keys using FIPS 142, -2 level validated. You can find some of this information in Artifact as we covered earlier. So let's create the cluster. Select your VPC. We only have the default. Then we can select at least 2 AZs. Okay. We have 2 here. This is for high availability. And then we can choose for FIPS or non-FIPS. Let's choose FIPS. And this is going to take the HSM medium. This is the capacity of the keys across the cluster. And then network stack, we'll do IPv4 just for pretty safely, just for safety, and then availability. And we're not using that many IPs. All right. And so we can create a new cluster, restore a new cluster, or restore from a backup. All right. At this point, we'll click next. What's the retention period? 90 days is usually good. You can set it lower if you'd like. 30 days is a pretty good one as well. Next, add your tags, which is good for your cost, and allocating information about who is working with this. Click next. And then you review this and click create. Okay, so with this, you want to look and understand about key control, whether it's user managed or AWS managed. Access control. So is this the HSM local users or if you have someone on-prem? Your availability, what's built in versus what you have to design. Your logging and monitoring, which is also going to be tracked in CloudTrail. Your use cases, it's going to be about encryption. So that means how are you going to make sure this is encrypted? How do you going to manage your keys? And then what VPCs is going to be with? So with this, you can do this with replication, or you can do this with subnetting, depending on how you're going to configure this with VPC peering. And then how much is it going to cost? So there is a free tier for KMS, but for HSM, there is not. Okay, and then let's go for some more KMS. All right, let's cancel this out. Let's go for KMS as key management system or key management service, excuse me. All right, and so we look at the hamburger and see, I would suspect it's under security, identity, and compliance, and I would be correct. Okay, so key management service is a fully managed encryption service that provides centralized control over cryptographic keys to protect your data. It's very similar to HSM. So it's a cornerstone of AWS security architecture. It integrates with most AWS services and provides the foundation for implementing encryption at rest and in transit across your infrastructure. So here's some core concepts. There's symmetric keys. So with symmetric keys, you have a single 256-bit encryption key for both encrypt and decrypt operations. It's used by all AWS services that integrate with KMS. It's required for envelope encryption, and it's never accessible in plain text outside of KMS HSMs. Then you have asymmetric keys. So this would be RSA, ECC, or SM2 key pairs, typically called public-private. So the public key can be downloaded and used outside AWS. You'd use this for cross-platform encryption and digital signing. And the private key would never leave KMS unencrypted. That's where the envelope comes in. Then you have HMAC keys. These are symmetric keys for hash-based message authentication codes. These are used for generating and verifying MAC codes. These support pseudo-random number generation. So in the key management, there's different categories. You have customer managed keys, where full control is handled by the customer over the lifecycle and policies. The customer can also enable and disable, rotate and delete the keys. It's required for advanced security, and it's used for envelope protection. Then you have AWS managed keys. These are created and managed by AWS services like S3 or EBS. There's automatic yearly rotation. They can't be deleted or modified, and they're service-specific usage only. And then there's AWS-owned keys. These are used internally by AWS across multiple accounts. They're not visible in your account, and there's no customer control or visibility. So how do we create one? Let's go, we're in the KMS console. Let's select this. Let's try symmetric key, which is typically the most common. Let's set for encrypt, decrypt, and the keys. KMS, we'll select this for recommended. Single region. So you want to do this when you're trying to meet compliance based off of where you're serving your customers. You can have it single, you can have it replicated across multiple regions. You can go forward wherever your applications or your workloads are being processed. And you can create an alias. This is like a friendly name. So this would be, let's say, my web application oops, web, my web, pet application key. Okay. You can add a description, just copy and paste this over here. Add tags for governance reasons and cost regions, though this doesn't typically cost. You can add administrators. So I'll add these 3, and you can add the roles as well. And then go for next. You can add key usage permissions. So you select the users or roles who can use the key for cryptographic operations. And these can encrypt, decrypt, or generate keys. So click for this. All right. And then click next. And then you'd review the policy. So you'd see this policy on this account for these users allows these key KMS operations. And on the key usage permissions aside as well. All right. And you'd click next. You go to review. And then click create or finish at the bottom. So then you have to manage key rotation. Let's finish this. All right. So we're at the key in the console. Let's click this. And there's certain things you can do. All right. So you can enable, you can disable, you can delete, or let's click in here. All right. Let's see. Schedule key deletion. There, rotation. All right. So rotation is available for customer managed keys, right? And immediate rotation is available without waiting for an automatic schedule. It's useful for security events and compliance requirements. Then you have manual rotation, right? So you see that rotate now button. This is to create a new key with a different key ID. And this updates, and then you can update the alias to point to the new key and keep the old key active for decrypting existing data. So let's go back to the keys and show you. Okay, multi-region keys. Now, why are they? Multi-region keys enable this encryption in one region and decryption in another without cross-region API calls. So you create a multi-region key in a similar way, right? Advanced, multi-region. And this would be created, so selected that. Let's see, my web application key, my web application, multi-region key, right? Just delete that, delete that. All right, the tags, and you can replicate this to other regions as needed. Okay, you can add whatever users you'd want for admins and for permissions users, and you can create this, review this. You cannot change the key configuration after. Click finish. And so this would be used for something like a global DynamoDB table with client-side encryption, a global Aurora database, disaster recovery scenarios, or cross-region data replication. Excuse me. Next, you have envelope encryption. So why is this used? So KMS has a 4 kilobyte limit for direct encryption. For larger data, envelope encryption uses a data encryption key, which encrypts your actual data, and then a KMS key, which encrypts the data encryption key. So how do you do this? So you have an application that's called Data Key API. KMS would return a plain text key, data encryption key, and encrypted DEK, right? So the application would encrypt large data with the plain text DEK, and the application would store the encrypted data and the encrypted DEK together. And then the application would discard the plain text DEK from memory. And then to decrypt this, the application would retrieve the encrypted data with the encrypted DEK, and then call the decrypt API with encrypted DEK. And then the KMS would return a plain text DEK, and then the application would decrypt this data with plain text DEK, and then the application would discard the plain text DEK from memory. So this is a simplified version of this, right? This is good to have encryption to encrypt a resource with an encryption key, and then decrypt it with a resource, decrypt that resource and encryption key with another encrypting key, and then discard that. Okay, so it wraps it and then wraps it with a key that can decrypt everything. All right, so for best practices, you want to make sure you have cross-account access when available. You want to have conditions for keys, You want to have external IAM policies. And you want to make sure that you can integrate this with your code. Meaning, if you're going to construct this infrastructure with Terraform, you want to make sure you have this set out so that everyone can see what's actually constructing it, which is a lot more detailed than doing it in the GUI as we're doing. So with this, you can monitor this with CloudTrail, CloudWatch, and you can go to the billing section. So with CloudTrail, all the KMS APIs would be logged, and they'd be monitored for unauthorized key usage. With CloudWatch, you could see the number of requests that succeeded or failed, and you could track the APIs. And then for the cost, you'd be able to look at the S3 buckets for operations like get bucket, list bucket, delete bucket, etc., and monitor the call volumes. And then you'd have to look at how this would work with other resources. But in general, this is going to be how do you encrypt things at rest and in transit. Okay, let's go next to Secrets Manager. Okay. So this is how you would hide secrets in your environment. So let's go security identity compliance. I believe it would be, yeah, right there, Secrets Manager. Okay, so Secrets Manager is another fully managed service. So this helps you protect access to your application, services, and IT resources with upfront investment or ongoing upfront investment or ongoing maintenance costs. So it lets you easily rotate, manage, and retrieve credentials, API keys, and other secrets throughout the lifecycle, right? So Secrets Manager has several things good that are great about it. Automatic rotation, so that it's built in with Lambda functions, database integration that works with RDS, Aurora, or DocumentDB. And its pricing is low. I think it's 40 cents per secret per month, and it could be 5 cents per 10,000 API calls. It allows for cross-region replication, so you have multi-region secrets. It allows for secret generation, so you can automate generation on rotation, and you can encrypt it, so you can have envelope encryption with KMS. So let's do a little walkthrough here. Store a secret, new secret type. Let's say other type, all right? But you can do this for everything. Well, not everything, for very specific things, all right? So with this, let's say username, password. What you want to do, let's see. You want to enter this as though you have the key value pair. Okay. Let's say username. Let's say Jenkins. No, Jenkins username. Um, admin. You would have something a little more complex. Okay. Jenkins password admin 123. Okay. So you have all this here. Then let's go next. Then you name this. So you call this Jenkins credentials. All right. Add a description. You can add tags for governance or cost reasons. Add extra permissions if you like. So here's an example of a JSON permission you would add. All right. So to say for your applications, the secret manager can get this, and then you can go forward with that. All right. Yeah, I figured your kid continued. All right, let's click next. Oops. Jenkins credentials. Yeah, next. And then you can set up rotation over here. I think automatic rotation is really good. And I'd want to do it every 30 days. Okay. You can set the time and hours are optional, and you can rotate it when it's stored, but I'm going to keep that off. And you can have a Lambda function and create that. You can use an existing one if you already have one, or you can create one. And it'll typically be auto-generated for the supported databases. All right, click next. Oops. Oh, so let's try and create one. Da, 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 da. The function, Lambda function is invoked, the payload. Yes, I thought. CI/CD. notifications. Let's just do that. Source code. Oops. There's a source code for it that you can use. All right. Installation. Use the runtime language. You complete this. It's a Node.js code commit and create it. All right. We're not going to do that. I'm going to shrink that off for automatic rotation. And then you'd store it. Okay. And then we're going to delete this after this. All right. So then after this, you can view the secret details. Okay. So you can see an overview of everything here for all the secret information. You can see some specific details, edit some permissions. You can get the secret value. So this is all available. Typically, this will be blocked out, but we'll close that. And then you can see the rotation period, which we disabled. You can see the version of it, if this is current, if there's a pending version, or if there's a previous version. You can see if this has been replicated across different regions. And then you can see tags as well. Okay. You could do it via the CLI, but we're not going to cover that here. But I just want you to get familiar with what secret is and why it would be used. So I'm going to delete this. Minimum period, 7 days. We're going to delete that. We don't need that. Okay. We're going to close that. All right. And that can integrate with everything from your Lambdas, your EC2s, and it can be created with your infrastructure as code as well, which helps you to have it dynamically be able to be updated and work for your security. And it can work to do your monitoring so that every time that secret is used, it will be logged. Anyways, next we're going to go to S3 encryption. Okay, let's go over here. So S3 encryption is very important. S3 is a comprehensive service for storage, right? So it has encryption capabilities to protect data at rest and in transit. And as of 2023, all objects uploaded to S3 are automatically encrypted with SSE S3, that's server-side encryption. So, and this doesn't have an additional cost. So understanding S3 encryption is crucial for any professional implementing a secure cloud architecture and maintaining compliance with frameworks like NIST 853, FedRAMP, or HIPAA. All right, so there's different encryption methods that you need to recognize, which we've gone over earlier, but SSE S3 is AWS managed, so it's a default encryption and pretty simple. There's SSE KMS, which is a customer and AWS customer managed with AWS managed keys. And this is pretty granular and allows for audit trails. And you can throttle APIs as well. And then there's SSE for customers. This is customer provided. And it's an external key management, and you can use that with CloudHSM. And then you have the dual layer, which is customer managed and AWS managed. And then you have a client side encryption, but most folks don't really use that unless they have a very specific on-prem environment that they need to. So we're in S3. We can go to our bucket. Go to the properties tab. Okay. And you can see the default encryption over here. Okay, so we could also create a bucket as well and go over this. So you should look at this. So what's some characteristics of SSE S3? So the algorithm is encrypted with is AES 256-bit, right? So this is fully managed by AWS. And there's a header required. And it's typically following. Post this in the related. X AMZ server side encryption AES 256. That's what's just going to be in the header. That's been enabled since 2023. Okay, so how do we do this? We can enable it. We enable it over here, bucket key. We encryption type. We select this, and we'd save changes. All right. So in this, you would have default protection for most workloads. You'd have compliance with basic encryption requirements, and it's a very cost-effective encryption solution. Then you have server-side encryption, which is an AWS. Oops, I clicked the wrong one. My apologies. All right. Then you have the server-side encryption. This is managed by AWS, and this is your own KMS key, All right. And it's enabled to reduce KMS API calls by about 99%. All right. So typically the user would upload the object, KMS would generate a data key, and the object would be encrypted with the data key, and then the encrypted data key would be stored with the object, both of them in S3. Okay, so here's some KMS API quotas. The regional quotas have about 5,500 to 30,000 requests per second, which varies by region. There's a throttling risk, so high throughput applications may hit limits, but the solution for this would be able to enable S3 bucket keys to have a significant, I believe, 99% reduction in KMS calls. And then you have a server-side encryption, which is customers provided and managed. AWS doesn't store the encryption key, and it requires HTTPS. Okay, and then you have a dual side, where you have two sides of this. So let's get this. All right, let's get a little bit. So this applies two layers of encryption to objects when they're uploaded to Amazon S3. So this helps you easily fulfill compliance. It requires you to apply multiple layers of encryption. All right, so the KMS keys must be in the same region as the bucket. Also, when it requests the object, the S3 checksum as part of the object metadata is stored in the encrypted form. So this is a metadata requirement along with the AWS managed service. So this has a slight difference to it. Okay, so you can have a put the policy, deny unencrypted objects. So the metadata here would have to match with the key requests. So it's this XAMZ encryption header, and it would be encrypted and managed by AWS. So this would be really good for really stringent requirements where you need to have dual encryption from the server side, from the client side. And it would be good for all encryption in transit and at rest, especially at rest. Okay. So how do you want to perform this? Basically, you have a couple of things you can look at when you're looking at this. Basically, you can do an encryption policy to make sure that this is enforced, which the KMS implements. You can do a default encryption, which you've covered as well. You can update bucket policies themselves to make sure that there's specific encryptions. You can do permission sets as far as who's able to access this, which complements the KMS, right? And you can integrate this with your infrastructure as code to make sure everything is encrypted and enforces the encryption and make sure that the bucket is as secure as possible. You can also do this with AWS's CloudFormation template, and you can automate it with your pipeline as well. And don't forget, you can also monitor what's going on here. Look at your metrics, okay, and your management, okay. Start to see lifecycle. You can see some information on your access points, and this would be able to monitor as well. So all of this can be tracked over time. All right. But what this would ultimately do is calculate things like your number of objects in your bucket, the bucket size, any requests that failed, and any activity that takes place within the bucket, typically, especially uploads. All right. Let's see, what do we want to do for this? So here's some compliance that works with this, and specifically, so you know this for your career. NIST 853 would revolve around transmission confidentiality. So with this, you'd have HTTPS enforcement via the bucket policy, and CloudTrail would be able to show that the messages and connections are encrypted. Then you have a protection of information at rest. So the server-side encryption with the KMS and customer managed keys would show that S3 inventory reports have an encryption status to show that this is active. And then you'd also have event logging via CloudTrail, which integrates with the KMS on this. And it would show logs of the encryption key usage. You'd also meet compliance with FIPS 140-2, which would show that KMS keys stored would be stored at level 3 HSMs, and AES 256 encryption algorithms. And you'd be able to document this for your compliance so that when you get audited, you'd show that administratively you have access controls. Then you'd have physical data security via AWS being responsible for it and their server-side encryption. And you could be able to show that you have encryption in transit and at rest. You also have, let's see, go to objects. Let's see. You could also do something along the line of object life cycles. Let's go into this a little bit. All right, so within a bucket, you do have different tiers. This is going to be in your lifecycle policies. So typically, they're going to be at standard to start, and you can move this down with your lifecycle rules. So this will move it to a less frequently accessed and cheaper version. This is good for your audit capabilities for long-term storage. But remember, when you have this type of situation, you have to have versioning enabled. You have to have an object locked enabled. And then you should make sure that everything is set up correctly for your timetables to meet compliance rules with your local rules and regulations. Then you have to remember that objects cannot be overwritten by this once enabled, and the retention mode can't be changed. So you need to be assured of what's going on. Also, the retention period can't be shortened. So this would be very suitable for something like the SEC or FINRA, financial institutions. They want to keep 2 years or 7 years or 14 years worth of data. And you want to make sure that anything you have for legality has to be independent, cannot be independent of the retention period, and you have to protect the objects indefinitely. All right. So you can put a command on the permissions line that is basically S3 put object legal hold. Now this can be applied or removed by authorized users, but it's very useful for you. And then you can do an immutable long time lock where you can move it down to Glacier, right? Which is for long time archival usage, right? So you can attach this lifetime policy and then create the lock policy. And then you'd be able to lock this up for a year, 2 years, 10 years, 15 years. All right. So when you do this, you can set the rule scope to limit this for one or more filters, apply to all objects in the bucket. And then you can start the transition between the storage classes, right? There's charges here. You can do a lot of different setups. So here would be the stages. IA, infrequent access, intelligent tiering. This lets AWS decide. One zone IA, this is a little more unstable. And you can see here once a month, once a quarter, formerly Glacier. This is Glacier Flexible. This is long term, and then Glacier Deep Dive, right? So this takes a longer time to retrieve it, but it will be stored. Okay. And you can replicate this across regions. Once you replicate this across regions, it ensures you have to consider a couple of things. The source and destination buckets have to be version enabled. You have to have an IAM role for the replication, and that you can replicate this to different AWS accounts if that's what you're trying for. All right. And then remember that the encrypted items will remain encrypted in the destination. And you can change the encryption type during replication, and the KMS keys must be accessible in the destination region. So you think about how you're setting up your keys as well as your buckets for this. Okay, so let's go into this. Here we go for replication rules. Okay, you click on this. So then you'd enter, you see, this hasn't have it enabled. All right, so this would be replication 1. All right, you have the status set up, your source bucket. How do you want to limit this to the objects or enable it for all your tags, which your destination? So you have to look at S3 for where this would go to. Any IAM roles that you want to attach to have specific permissions, and then whether you want this encrypted, which you should, in your storage class for how you're going to do this, and then any additional controls. So replication time, the metrics, which would be good for CloudWatch and CloudTrail, so you can monitor this. And then your marker replication and replica modification sync, right? So these are lifecycle policies and bucket destination policies. But we're going to cancel out of that. All right. All right. But this will let you be good for monitoring your costs, monitoring your buckets, monitoring across buckets and across regions. And then you'd have to weigh this on how you do this within your organization. But for the exam, you really want to know what type of encryption you want to use. So you can use the default SSE S3, the cloud managed, or the customer managed, or the AWS managed, or the dual side for maximum control. And you want to consider your performance considerations for throttling via KMS and your costs too. Then you want to see about your bucket policies versus IAM policies and decide when to use this, whether this bucket has to perform something. How do you enforce this to deny unencrypted loads? How do you want to use this cross account? What keys are you going to use and any headers? And then how are you going to make this compliant, right? What are you going to do to lock the objects, move the buckets to different life cycles, whether that be infrequent one zone, or glacier deep, right? And then how do you track this for compliance via CloudTrail or CloudWatch? And then what do you do for integrating this within your automation via infrastructure as code, right? How do you integrate your keys? Are they going to be multi-region, single region, along with your bucket? And then what are you going to do to troubleshoot this with CloudWatch beyond just auditing? All right, so let's go through load balancers, which we've touched on a little bit earlier. So we go load balancers. Okay. Click load balancers. I believe this would be under compute. No, maybe under network. Oh, I really didn't think so. Now where would that be? Maybe. Wow, I'm not seeing it. Why am I not seeing it? Huh. Okay, give me a little bit of time. Shoot. I thought it would have been here. I for sure thought it would have been there. Why am I not seeing it? Am I missing this? All right, let's see. All right, we're in EC2. So this is load balancers. All right, so let's create one. So a load balancer basically distributes incoming application traffic across multiple targets, like an EC2, a container, or an IP address. And it works in multiple availability zones. So this increases the fault tolerance of your applications, and it's essential for building scalable, highly available architectures to meet enterprise security requirements. There's different types of load balancers. There's an application load balancer, which operates at layer 7, which is on the web layer, the user layer. And this features content-based routing. Then there's a network load balancer, which operates at layer 4. This is going to be for high performance and static IPs. This is good for network security and high performance applications. Then you have a gateway load balancer, which is going to be at layer 3, right? So this will be for third-party appliance integration. So this will be good for like firewalls, intrusion detection, or data protection solutions. And there used to be a cloud classic load balancer, but they've since retired that. No, there you go. See, it's right here. So this can run on a lot of different things, but they made it more customized. The classic load balancer works on layers 4 and 7. This is a legacy tool, but it's being deprecated. Okay. So how do you create this? Let's go ahead and click on which one. Let's try an application load balancer. All right. So let's call it my secure app LB. All right. So we want to do internet facing or internal. We'll stick for internal. Okay, we'll have it on IPv4. We won't need that much. We'll stick with this VPC. We'll have, let's see. let's select two subnets. Two. I don't know why that's like that. And your security groups. All right. And you want to configure this so that you have port 80 for HTTP, I don't know, port 443 for HTTPS. And then for outbound rules, you want all traffic going outbound for destination 000, the 40.0.0.0, which is the default. All right. And then you can do your listeners and routers. So for HTTP, you do it for port 80, or you could do HTTPS and select the 443, and then forward this to a target group, but we don't have anything set up for this. And that could be an instance, an IP address, or a Lambda function. And then for that, once you select that, you configure that with HTTP or HTTPS, and you'd have an application port, which would be either 80 or 8080. And then you configure, you don't need an additional listener. So this has a policy already set up here for TLS 1.3 for security. You have your certificate defaulted from ACM. And then you could select the optional tags. And then there should be, I have a health certificate. And you create that load balancer. But there should be, I was looking for a health. Let me see. Nope, I don't see it. No, there is usually a health check, so you can configure this to make sure that everything is running well. And the process is roughly the same for the network load balancer. So but the network load balancer, you'd be worried about TCP, UDP, or TLS instead of HTTP and HTTPS. That would be significant different. And the gateway load balancer, this would be for the security appliances. You'd be configuring this with a different port and a different protocol. The protocol would be Genève, and then the port would be 6081. And this would be for firewalling. All right. So with this, you also have certificate management, which we'll go up to. Let's go over this a little bit to see right here highlighted. So when you have this set up, make sure that the certificate is set up. Select it from the ACM, the certificate manager, or you can import one if you have it already. And then you'd make sure that you have your security here and be able to make sure that your security was configured for transit, for information in transit. All right. And this is about access, this is about encryption, and this is about TLS termination and encryption. Okay. With this, you could also create a WAF or an ALB, which with an application load balancer. So that application load balancer would allow for different configurations for security, right? This would be for rate limiting, for IP reputation, allows geographic blocking, SQL injection protection, or cross-site scripting protection. Okay, and you can configure this with infrastructure as code as well, which will be a lot more proficient. You'd add the load balancer, the listener, all as separate resources and be able to launch this from your desktop. Or from whatever your source control is. It can be Bitbucket or something along those lines, GitLab, any of things. You'd also be able to establish alarms, right? So those alarms will be able to work for CloudWatch, where you'll be able to see how healthy or unhealthy the load balancer is. And you could do that for different dimensions around the application load, the host. You'd check for latency. You check for certificate expiration. There's a bunch of different things you could set up to configure for this. And once you have it set up, you can troubleshoot any issues with the load balancer. You could do it in the GUI or in the CLI, and then make sure everything is enabled, hardened, and ready to go for any targets you needed to apply this to. Okay. So let's see, a couple of things you want to make sure of. If you want to create a decision tree for why you're using the load balancer or using it for performance on your network, then you probably stick with the network load balancer. If you're using this for application facing with content, use the application load balancer. If you want to use with security appliances, like intrusion detection, then you use the gateway load balancer. But if you had something with but remember, there's other things you can add too. Like you can make sure that your load balancer is chained with your security groups from your load balancer to the target. And then you can make sure that everything is encrypted. Make sure that you have SSL, TLS enabled and on this along with your listener. And if available, make sure you have appropriate health checks to make sure that everything is working well. And this will work with your CloudWatch too. All right. All right. Next up, we'll go over AWS backup, which we touched on a little bit before, but we'll do here. AWS backup. How'd you look at this in the menu? So I would probably find it in storage. There you go. So you can create and manage this backup here. All right. So you can create a backup plan. So this is a fully managed service that centralizes and automates backup operations across the entire AWS ecosystem. All right. So this is critical for implementing comprehensive data protection to align with NIST 853, FedRAMP, High Trust, or HIPAA. All right. So unlike traditional backup solutions that require custom scripts and manual processes, AWS Backup is a unified platform that integrates with your CI/CD pipelines and your infrastructure as code practices. So in a modern cloud environment, data protection isn't just about backup and recovery, it's about compliance, governance, and security orchestration. And AWS Backup addresses a couple of key requirements as centralized management. So it eliminates the need for service-specific backup scripts across EC2, RES, DynamoDB, other AWS services. It has compliance integration. So it provides WORM, which is write once, read many capabilities through the Vault lock for regulatory compliance. All right. It's cross-region or cross-account support. So it can enable disaster recovery strategies to meet geographic and organizational requirements. It has tag-based automation, so that it integrates with tagging strategies for environment-specific backup policies. And it has point-in-time recovery. So it'll support granular recovery options for mission-critical applications. All right, so this goes over a lot of different services around compute and storage and databases, and there's hybrid situations as well, like storage gateway or VMware environments. All right, so how did you do this in the console? We showed you go to storage. Let's go to dashboard again. We create a backup plan. See a couple of different options, the template, new plan, or define it via JSON. All right, so this start with the template is that's good for beginners. The new plan is good for custom requirements, and the JSON is good for infrastructure as code integration. All right, you name this practice backup. All right, then you'd set up what you have for your tags for the automation. You can add rules like daily backup plans. Then you can set up integration with Windows VSS, which we're not going to do. And you click create the plan. All right, we'll try and do that. All right. And then you could do stuff like assign the resources, right? You can name this, include all resources, include specific resources, and exclude specific resources from the selected, and then refine this with tags, okay? Once you're here, let's see, let's cancel out of this. Okay, so in this backup, so we can go through this and examine a lot of stuff that goes on. Let's go for daily backup. You can see a lot here, like the rule name, the backup vault, if that's enabled, the frequency, the window, um, the cold storage transmission, and the retention period, and any copy destinations. All right, and then you can go back and see, and you can edit that as well. And you can see what the schedule is for this, if there's any cold storage attached, or if there's any retention periods that are here. All right. You basically want to make sure that this is all up to date for what you actually need, and then align this with what your organization needs. Right. And for the resource assignment, this is after the plan is created, and you can name this whatever you need relevant to what you created. And you could choose an IAM role based on two different types. Let's go for this. You have a default role, or you can choose one. The default role is when AWS creates necessary permissions automatically. This is good for anyone who's a beginner, and it's pretty much recommended. Or you can choose an IAM role using a custom role with specific backup permissions. And you have your resource selection strategy, which we covered in brief, with two approaches. One, you can include all resource types, and this is tag based, right? So if you do this, it'll approach this using tag based filtering, and you can have an example with your tags like your key would be environment, your value would be production, right? So it'll tag any resource with the following. Let's see, environment. Let's say contains production. And anything tagged with this would be backed up, right? Or you could do specific resources, where you could do something like DynamoDB, RDS, EC2, and specify individual resources or use tags within those service type. Once you complete it, you hit assign resources and finalize the configuration. So what do you need to understand about the backup ecosystem? One, there's basic vault concepts like the default vault, which is it's managed by AWS with standard encryption. There's a custom vault, which allows custom KMS keys and access policies. There's a vault lock, which implements worm policy for compliance, and it cannot be reversed. Then you have monitoring, right? With this, you can have backup jobs, so you can schedule on-demand backup jobs and operations. You can restore this, so you can recover this operation and its status. And you can have copy jobs where you can copy cross-regionally across account with backup copies. And you can do some advanced features, backup policies. All right, so you can have organization-wide backup governance. You can do cross-account monitoring, where you start going into CloudWatch and CloudTrail. All right, and you could do different ways around this with specific instances like, an EBS, RDS, etc. But you should get practice on this because this was really good for disaster recovery architecture. All right. And then remember, there's a couple of different things where this will be useful when it comes to the vault lock, any type of encryption, any type of IAM integration or monitoring and auditing. And this can be used with infrastructure as code as well. All right, so let's go to our next piece. Lifecycle manager. Okay, so lifecycle manager. There's also an EC2. All right. So data lifecycle manager is a service for automating backup and retention policies in AWS environments for something like EBS snapshots, EBS backed AMIs. So this is good with the frameworks we talked about with compliance. And it provides an automated data protection that aligns with regulatory requirements for backup retention, cross-region disaster recovery, and audit trails. So why is Lifecycle Manager important? So a lot of times, manual backup processes are a significant security and compliance risk. But DLM, Data Lifecycle Manager, has automated compliance. So it eliminates manual backup processes that can lead to compliance gaps and human error for cross-account security. And it enables secure backup sharing across organizational boundaries with proper access controls. It has tag-based governance, to integrate with infrastructure tagging strategies for automated policy-driven backup management. It also has audit trail integration, where CloudTrail will store and log for all lifecycle management activities. And there's automated retention policies to prevent unnecessary storage costs while maintaining your compliance. Okay, so you can do this with, let's say, EBS, EBS backed AMI, or cross account, right? So this has, for EBS, you have automated creation, retention, and deletion of EBS volume snapshots. You have cross-region copying for disaster recovery. You have fast snapshot restore for rapid recovery scenarios, and incremental backup technology for storage efficiency. For EBS-backed AMI policy, you have automated AMI creation from EC2 instances. You have version management and deregistration of outdated AMIs. You have cross-account sharing with security controls and integration with instance patching workflows. And then you go to, let's see, how would you access this? One, let's go here. Let's click next. Oh, sorry. Uh, let's see. Yeah, let's create. Yeah, let's do that. Okay. So we have the default policy, which we select. No, we selected custom, didn't we? Yeah, we selected custom. Okay. So custom is a tag-based targeting. Default backs up all volumes without recent backups. Okay, so let's try default to show you that one. That might be too simple. Let's try custom. So it's up top. All right, so you select that. You get a description of the target resources, volume of the instances, and then you could check environment. Remember, tagging is key development, right? And add that. And then name it development backup. Okay. Add IAM roles. You have a default role, which will be automatically created, or choose another one that's more specific, right? Add tags necessary to this, maybe to match this. All right. Policy status enabled, which is always useful. And then you could be okay to go. All right. And then you can create a backup schedule. And you could do this for a specific time, let's say 3 a.m., 12 a.m., whatnot. And it will let you select how long you retain it, and if you want to keep a similar number or specific number of backups. So you can keep 5 of them over, 50 days. Every 10 days, you create a new backup. It just depends on how you want to create this. And you can have a fast snapshot restore. So you can have critical volumes having rapid recovery, right? And you can configure this to jump from your current region, let's say US East 1, over to US East 2 or US West 2, right? And then be able to target this for the accounts to deploy for your environment and any other tags you have. You can also create cross-account snapshot sharing so that trusted accounts will have the information to be able to restore from what you've backed up. And you can monitor this with CloudWatch and CloudTrail. So you can see the metrics about any policy executions or any backup failures or missed schedules and track the snapshot storage costs. And then with the CloudTrail, you can do API logging for any operations logged and generate a backup compliance report. And you can monitor who modifies any lifecycle management policies. So within this, you can recognize that data protection and backup security are important. Identity and access management are relevant. How this works with compliance and how this works with monitoring and incident response. All right. I think this will be our last one. Let's see, Nitro. This is something a little bit, it might be. Hmm. Let's see. Maybe that our region was preventing it. Nitro. No, it's not here. Wow. That's not what I was looking for. Huh. Wow. So this might have been deprecated. Let's see. Oh, so this is built on the EC2. Okay, let's go over here. EC2, maybe? No. All right, well, we'll have to do this with just this information. I don't know why I'm not able to find this. What is this? Let's see, what is this? So, okay, it is in the EC2. Okay, let's go over Nitro Enclaves. All right, so this is a way to have secure computing within the AWS ecosystem. So it has hardware level isolation for processing sensitive data. Okay. So this is a different approach to computing, to confidential computing beyond traditional network-based isolation. So why is this unique? So traditional approaches to secure data processing in the cloud involve creating isolated VPCs, strict network access controls, and relying on application level security. So these are very effective, but they still leave sensitive data vulnerable to privileged access, hypervisor attacks, and administrative oversight, right? But Nitro changes this by providing hardware level isolation. So unlike containers or VMs, virtual machines, Nitro enclaves are isolated at the hypervisor level using AWS's Nitro hypervisor. This creates a boundary around sensitive processing, and it is a zero trust architecture. So there's no persistent storage, no SSH access, and no external networking, and no interactive access. So it has a zero trust environment where only verified code can execute. There's also cryptographic attestation. So every enclave provides cryptographic proof of its identity and the code running within it, enabling zero trust of the computing environment. Let's see if we can open that image up. Okay. That's interesting. And there's KMS encryption. So like native integration with AWS KMS, make sure that only attested enclaves can access encrypted sensitive data, and it creates an unbreakable chain of trust. So this would be used for something like payment processing, right? So you'd have a PCI DSS compliant credit card processing with cryptographic isolation, or healthcare information, right? So you'd have HIPAA compliant processing of personal health information with hardware level protection, or you'd have um, FedRAMP, right? So you'd have environments that, like in the federal government, that require hardware level isolation, and you could do something for machine learning, right, where you could train models on sensitive data without exposure. So there's a lot of interesting ways that this could go. So this would be done through the CLI, and I'm trying to figure out how would be the best way to do this. Obviously, through the CLI. So let me give you an example code of what that would look like. Okay, let's, oops, I don't know what that is for. Huh. All right, so in the CLI, we'll show you what this looks like. But yeah, you basically want to run an instance. I don't even know if this will work. Basically run an instance like this. Let's see if that actually does something. Yeah, that's not it. All right, so you launch that instance with those specific configurations. So say you know the AMI, the instance type, have the key pair created, security groups lined up, the subnet information, enable the enclave, have the CPU set up, and then any tags that you want, right? And then you could install the Nitro CLI with a sudo yum, right? And then you could sudo yum install Nitro, right? So this would install Nitro Enclave CLI with AWS Nitro, okay? And then you could add the user. So you could add your user to that enclave. What the heck is that? Uh, Add this, right? Add the user to the enclaves, and then you'd enable and start it with when you're in this EC2, right? Now you're in this, able to activate, and you can configure your memory and CPU for this, right? With the following, right? So you enable this two CPUs, the allocator YAML, And then, well, it doesn't have this here. And then set up the memory at boom 248, 2048. Okay. And then let's cancel that. And then you could restart the service with the following once you're in. Okay. And then clear. So I'm not going to do this. And you'd verify it with the following, right? Make sure it's updated or installed. And then verify the allocator with the elevated privilege. Check any resources. All right. Oops. And then you'd be able to see everything working. Right. At that point, then you can deploy an enclave application. So if you want to do that workload, right, you could do any Python or PyTorch or anything. You could do a Docker file. You could build an image file with Docker. You could do a KMS policy for it, right? There's a bunch of different things you can do to create all this and run what you need within the Nitro Enclave. And you could do some communications with it. There is some CloudTrail monitoring to just see with the event history that it was created. And then you could do some attestations from it to get this to show that it was running, right, for your documentation. Okay. And then you could do it, you could create this with infrastructure as code, but that'll be a little more intricate because you'd have to have access to your environment first. So I'd say this is a very useful tool to have in your tool bag as far as anything you want for encryption, increased protection, confidential computing, and then you can monitor and make sure everything was compliant for any scenario on your side for their work environment. Well, this will give you, I hope this gave you a pretty comprehensive understanding of the security features, implementations, and compliance capabilities that are essential for the AWS Security Specialty and a working DevOps or DevSecOps personnel within the AWS environment. Next time, we're going to come over on and talk about management and security governance. Until then, thank you and have a good day.